the signals and system subject, another important topic is basic signals. So first of all, we'll go through the basic signals and what are those signals, how to represent in functional and graphical representation, right? And later we'll go through the some other signals, those are standard signals. So the basic signals. The basic signals are step signal, these are step signal, impulse signal, right, and ramp signal, and one more, parabolic. So these signals are called basic signals, and these are also called as standard inputs or basic inputs. And another name of these signals are elementary signals and singularity functions. These are the different names are there, because remaining all the signals are derived from these signals only. And in these signals, first of all we'll go through the from all these. First of all we'll go through the step signal. See, step signal, or we can call it as a step function. Step signal or step function. Step signal or step function. See, in one words, we can write signal and function, both are same, because function, according to the mathematical expression, the function consists of one independent variable and one dependent variable, and here we have to discuss one dimensional signals. One dimensional signals consist of one independent variable and one dependent variable. That's why, so now onwards we can write here either signal or function. So step signal or step function. And from this name here, so that name explains the shape of the signal is step shape here. So we have to take here, this axis is independent variable axis. Independent variable axis is time axis. From here to here, this explains the positive time axis, and this side it explains the negative time axis. And exactly here it is a origin point. And the shape of the signal is just like one step shape. Step shape is exactly defined at t is equal to 0, because now here we have to discuss all the basic signals positive time axis representation side. That means all the basic signals are defined this side, t is greater than the 0. T is less than the 0, these signals are not defined. If any application requires negative time axis signals, later we have to apply operations on the signals. Now I'm drawing the signal here. Negative time axis side signal is not defined, that means signal amplitude is 0. So this explains the signal, step signal. And this step signal is defined exactly at t is equal to 0 onwards. T is equal to 0 onwards, it has constant amplitude. It should be like this. Now see, the shape of the signal is just like one step shape. That's why this signal is called step signal, right? And this constant amplitude is, I'm assuming here, A. So it has constant amplitude. The amplitude value is how much? A value is there. A is a constant value. Let us take a 10 or 20 or 30, some other values. So this signal is defined from t is equal to 0 to up to infinity. See, t is equal to 0, what is amplitude? A. T is equal to 1, A. T is equal to 2, A. T is equal to 3, A. Up to infinity it has constant amplitude. These type of signals are called step signal. Now here I have wrote a complete ideal representation of the signal here, right? So now I want to write the functional representation. This explains the graphical representation, right? So this graphical representation name I am writing here x of t. That means x function is changing with respect to time. So this x of t function, x function is changing with respect to time. The time is from 0 to infinity. It has constant amplitude. The amplitude is how much? A amplitude. So now I want to write functional representation. The functional representation is always you have to write like this. X of t function has constant amplitude. How much amplitude? A amplitude. This amplitude is defined from t is equal to 0 to t is equal to infinity. So that's why we have to write 0 is less than or equal to t is less than or equal to infinity combination, right? So time axis changes from 0 to infinity. The amplitude of the signal is constant. The constant value is A. And negative time axis it is not defined. So right here this is equivalent to 0 for t is less than the 0. See, here clearly I wrote t less than the 0. Less than the 0 means it is defined from minus 0.000001 onwards, right? So minus infinity to up to minus 0.0001 up to this time period, the amplitude of the signal is 0, and from 0 onwards this amplitude is exactly A amplitude is there. This is generally we can write in ideal cases here. But practical cases exactly t is equal to 0, A amplitude is not possible. That's why we have to take exactly at origin, because exactly at time is equal to 0, the amplitude changes from 0 to up to A amplitude. So sudden increment is not possible. So practical cases the function is defined like this. It increases, it takes some time. It takes some time to reach that amplitude A. That's why always we have to take exactly at t is equal to 0 average value. So average value means now we can write like this, x of t is average value of this. So average value of this is here, generally we have to take a by 2, 0 plus a by 2, that gives the a by 2 exactly at t is equal to 0, and 0 for t less than the 0, and a for t greater than the 0. So greater than the 0 means 0 plus onwards. So 0 plus onwards the amplitude is a, exactly time is equal to 0, the amplitude is a by 2, generally we have to write always average value, and t less than the 0, the complete amplitude is 0. So this gives the practical definition, practical functional representation of the step signal, and this explains the ideal definition. Generally now onwards we have to take from 0 to infinity, amplitude of the signal is constant value, that value is a, right? So this signal is step signal. And another basic signal is defined, that is ramp signal. Ramp. See, ramp, the name explains here, amplitude and time both are directly proportional. So amplitude of the signal is directly proportional to the time. That means it is completely depends on the time axis. If the time axis increases, amplitude of the signal is also increases. So that relation is explained like this, just like it acts as a one straight line time axis, and this side I am writing here x of t function. The name of the function is x of t. So time axis and amplitude axis both are directly proportional, then the relation is just like it acts as a one straight line like this. And negative time axis side is not defined. This side it is not defined, only positive time axis side is defined. So positive time axis side, if the time axis increases, amplitude of the function is also increases. If the time is 1, amplitude is also 1. If the time is 2, amplitude is 2, right? If the time is 3, amplitude is 3. Sometimes it changes here. That is depends on the slope of this line. So slope of this line is, now I am assuming here a. Generally what is the general equation of the slope? Change in y-axis by change in x-axis. Right? So change in y-axis by change in x-axis explains the slope. Slope should be constant value, and the constant value is here how much? A is there. So now these two are directly proportional. This type of signal is called ramp signal. If the time axis value is infinity, amplitude of the function is also infinity. This gives the graphical representation of the ramp signal. Now we have to write a functional representation. X of t is equal to a into t. What is a here? A is slope of the line. Slope of the line here, right? So a into t. This is defined from t is from 0 to infinity. That's why we have to draw t greater than or equal to 0. Here I am writing directly t greater than or equal to 0. That means time axis is from 0 to infinity. The amplitude is like this. The function is a into t. Time axis increases, amplitude is also increases. Both are directly proportional. Negative time axis side 0. So t is less than the 0. The function is not defined, right? So x of t function is 0. T is less than the 0. This gives the functional representation. Now here I have wrote one step function and here ramp signal and step signal. And in these two here a is a constant slope. Here a explains the slope of the ramp signal, and here a explains the constant signal. If you take the constant signal is 1 now, so if you assumes here, if a is equal to 1, the constant amplitude is here 1, then this signal is called unit step signal. Then this signal is called unit step signal. So unit step signal is generally denoted as u of t. Please remember this one, because now onwards our complete subject, not only this subject, signals and system, control system, and some other advanced level subject, all the subject deals with the u of t signal. Wherever u of t is given, immediately we have to take the time limits of the given function is 0 to infinity. And 0 to infinity, what is amplitude? Amplitude should be 1, right? So u of t signal is defined from 0 to infinity with amplitude is 1, and negative time accessory it is not defined. This signal is also called as unit step signal. The function is like this: u of t is 1 for t greater than or equal to 0, and 0 for t less than the 0. This is unit step signal. Similarly, here if the slope of the signal is 1 now, that means if a is 1 now, if a is 1, then it is called a unit ramp signal. Then it is called a unit ramp signal. If a value is 1, then it is called a unit ramp signal. Then the function becomes like this: r of t. Please remember another important representation. R of t is nothing but unit ramp function. U of t is nothing but unit step signal or unit step function. So R of t is equal to t for t is greater than or equal to 0, and 0 for t is less than the 0. Right? So R of t is t greater than or equal to 0, and 0 for t is less than the 0. So negative time accessory is not defined. Only positive time accessory defined directly is equal to t. If the t is 1, amplitude is also 1. T is 2, amplitude is 2. Then the slope becomes how much here? 1. So this signal is called unit ramp signal. So unit step signal, and another signal is unit ramp signal. And one more signal is there, parabolic signal. Parabolic is a non-linear signal here. Parabolic is non-linear signal. That means the relation between x-axis and y-axis. X-axis is nothing but here time axis, and y-axis is nothing but amplitude axis. So the relation between these two is not directly proportional. So the relation is non-linear relation. It should be like this: exponentially increases or exponentially decreases. These type of signals are called parabolic signals. The parabolic signal standard functional representation we have to write like this: a by 2 into t square, t greater than or equal to 0, and 0 for t less than the 0. So please remember this representation. A by 2 into t square, here I wrote by 2, because if you perform the differentiation of t square, then it becomes 2 into t. To cancel the 2 purpose, there I wrote the constant function is a by 2. Otherwise you can write any some other constant value here, right? But the complete function is directly proportional to which function? T square function, not t. If it is directly proportional to t, then the ramp function. If it is directly proportional to t square, then it is called a parabolic signal. So parabolic signal is a non-linear function or non-linear signal. This gives the functional representation, and this explains the graphical representation. And another important signal is impulse signal. Impulse signal or impulse function. Impulse signal or impulse function. See, exactly at t is equal to 0, this function is defined. Exactly t is equal to 0, this function is defined. T is not equal to 0, this is not defined. T is not equal to 0 meaning is t is positive or t is negative, right? T greater than the 0, t less than the 0, that is comes under t not equal to 0. And exactly at t is equal to 0, what is the amplitude here? How much amplitude is here? The amplitude should be infinity. The amplitude should be infinity. This signal is called impulse signal. The definition is functional representation should be like this: x of t is infinity amplitude. Exactly at t is equal to 0. Exactly at t is equal to 0, the amplitude of the function is infinity, and other than the 0 it is not defined. That means less than the 0, greater than the 0, the amplitude function should be 0. This type of signal, this signal is called impulse signal, right? But practically this signal is not possible. Why? Because exactly time is equal to 0, generation of infinity amplitude is not possible, right? So practically this representation is not possible. That's why the practically expected impulse signal should be like this. The practically expected impulse signal should be like this. It is just like acts as a one pulse function. Pulse function means it has constant amplitude within the short time period, which has constant amplitude within the short time period. So this function here, but area of this function should be how much? 1. Area of this function should be 1. So then the function is called impulse function. So practical cases, exactly at time is equal to 0, generation of infinite amplitude is not possible. That's why practical cases we have to take within the short time period it has constant amplitude, but the area of the pulse signal is unity, then the signal is called impulse signal. That's why always we have to write like this. This representation is del of t. We have to write always, it should be del of t. So integration from minus infinity to plus infinity, del of t dt. Del of t dt should be how much here? 1. So it has to satisfy this condition, because integration explains the area. Area of this impulsive pulse signal should be how much? 1. So del of t integration is from minus infinity to plus infinity, del of t dt should be 1. Then the signal is called impulse signal, and it has to follow this representation. Del of t is infinity at t is equal to 0, and 0 for t is not equal to 0, and it has to satisfy this condition. Integration from minus infinity to plus infinity, del of t dt should be 1. If it satisfies these two, then the signal is called impulse signal. That's why here, if the duration of this pulse signal is delta, if you assume here duration of the pulse signal is delta, this amplitude should be 1 by delta is required. Then only it gives the area should be 1, because just like it acts as a one rectangle, right? So area of the rectangular is sides into breadth here. So this into this, so delta into 1 by delta becomes here 1. So it has to maintain this relation, then only the signal is called impulse signal. So all these comes under basic signals. One signal is step signal, ramp signal, parabolic signal, and impulse signal. So using these signals, now we have to define another new signals. Those are standard signals. Standard signals are generally our real-time application uses signals. These are also used, but practical cases exact representation is not possible. That's why using all this addition and subtraction of all the signal becomes some other signals. Those are standard signals. So please take this.